I know you're wondering why the Corvette guy is standing over a blue motor. Well, I'm not prejudiced towards a nasty running small block Ford. And of course, when you're loving your car and you got problems like this huge gap in the back here. This is a Crawford motor that he built years ago. I just had Ron Robart build me another set of heads and Cam Motion duplicate the cam that I had. Had a problem with one of the solid lifters that the needle bearings took a crap on one of the wheels. Needless to say, it scored up one of the lobes. So while I'm putting it back together, I'm like, hey, I got to deal with these crazy Ford oil leaks that everybody tells me they don't have. Well, here's the proof. You got about 220 thousandths here, and we're gonna make a set of shims in the front. That's the rear. We're gonna make a set for the front and the rear. I mean, even though it's a supercharged motor and it's vented very well, silicone's not gonna fill 200 some thousandths. There's no friggin' way. So the Corvette guy is gonna go into detail on how to solve this problem on a Ford. So don't be a hater. Now that you've determined the thickness of the plate that you're going to need to make to fit between the block and the manifold, now you have to figure out what the pattern's going to be. So just take a piece of cardboard, get it to fit in between the two heads on top of the block right here. And then you're going to want to draw a line with like whiteout or something, the outline of the manifold, and then make your line a little bit further out so that it's flat up against the block, so when you put the manifold on, you can just run your finger with the silicone along the edge of your plate that you're going to make. So take the cardboard, stick it on that line right there that I've chosen to use, and then hold it down, the cardboard down with with your hands. And then use a plastic mount like this, and then beat it, across the cardboard. You got to hold it in place. The other hand's holding the camera. And then you'll put a pattern on the bottom of the cardboard. Then take your cardboard, and like I said, you'll have the pattern on there. And then take a pair of scissors, cut it out, and you end up with your pattern. Okay? I cut along the edges after I had hammered it with the plastic mallet, and it fits just like I wanted it. Now you don't know how wide to make the plate, because you don't want the plate the width of the pattern, because then you're going to have this huge gap that oil is going to be coming out of every time you get on it. So, especially if your motor's supercharged or turboed. So what you're going to want to do is you're going to want to take a piece of the plate that you're going to use, lay it like right there, up against the head, okay? Then you're going to take a screwdriver or scribe, and then you're going to run it across the top of the plate and make a mark on the head. See, there's a mark here on the head. So it may be hard to see. You can see it right there. See that mark right there? Okay. You do it out on both sides. See the mark here. And then you're going to get your measuring device, a veneer caliper, cheap one from Harbor Freight Tools, and then you're going to measure the distance between the tops of the two lines you just made. Then you're going to want to make your plate that width. Okay? You're going to make your plate that width, which this one came out to be 5 inches, I think 725 thousandths. Let me see, I forgot what it was. It's yeah, 5 inches. $7.25. So okay, or 29, whatever. It's 7.17 I got. Okay, so you're going to measure between those two marks that you just made. Then you're going to, when you take your pattern and you lay it on top of the aluminum, your big plate of aluminum that you haven't cut yet. You lay your pattern like that, and then you're gonna measure the width of your pattern. Let's just say it's 5 inches. Then you're gonna take like 200 thousandths here and 200 thousandths here. And you're gonna make that plate that much bigger than your pattern. Okay? Then, after you cut your pattern out, it's not going to want to fit, inside where it's supposed to fit yet, because you have to grind, like maybe use like a belt sander like I did, grind the ends of the plate on the bottom so that it'll fit the taper of the head. And you can see that fits pretty damn good on both sides. Now, how much did I know how much to grind it? Well, I measured the thickness of this plate, which is 187 thousandths, and then I scribed in 187 thousandths from the edge. So you take, might seem confusing, but it's not. Okay, 3/16 is 187 thousandths. Or close to it. I mean, let's just go 184. And then you're going to run veneer caliper on the bottom now. I'm doing it on top. You're going to mark the bottom. You're going to scribe it all the way across. Takes 2 hands. And then you're going to grind it up to that mark that you made. You're going to grind it up to that mark, and then it should fit right on. And then don't make it too tight. You want a little loose, just a little loose, because you want to, when you put the heads on and everything's ready to go and you're ready to put your plate on, you're going to want to make sure that oil's not going to be coming in between that plate. Now, you are going to silicone it, but still, you want it perfect like that. Now we're going to get ready to drill the holes, mark and drill the holes on this plate right now. Okay, now we're going to put 2 screws in, 2 632 screws in, just to hold the plate in before we put a manifold on. You don't want to put silicone underneath it, and then you're going to screw it down. So you line the plate up to where you want it, and then you're going to measure the distance between the underside of the plate where it hits the webbing of the casting of the block. Now, what do I mean by like that? Like that. See where it's touching? Well, put your plate back on, and I measured 260 thousandths. So then you take that, you lay it on top, right there, and you get a marker and mark it. That way you know that you got this much room to drill and put a screw in. And you got to do the same for the other side. After you figure out where you're going to put your hole, drill a pilot hole with the size of the drill needed for the 632, which I'm using. But like I said, if you want to use 632, you got to be daring, because you might snap the tap off. It's so small. So I drilled the pilot hole through the plate. That way when you put the plate back on the block, after you put the tape on it and everything so you don't get dirt in the motor, when you drill through that pilot hole that you made, you can make your mark on the block and take the plate off and finish drilling the hole. Don't be a cowboy and accidentally drill through an oil passage or in a direct line with the... Now, before you drill the holes, make sure that you put tape down to keep the shavings, the metal shavings, from dropping down inside the lifter galley where you don't want them. Just put clear packing tape down, and then just drill right through the tape, and then you can use the air blower to clear the hole out, and then when you're done, just pull the tape off, and then you won't have to worry about any dirt getting where you don't want it. Now, the size of screws that I'm using for this are 632. Now, number 6 tap can be a very dangerous tool, so make sure that that you don't snap the tap off like I did. I already snapped one off, which is right here. Snap the tip off. But if you have a dental tool, you can work it out. So just make sure that when you're going up and down, you know, a couple turns down, and then a couple turns up, a couple turns down and up, you know, progressing all the way down to the bottom, or as close to it as possible. Every time you pull the tap out, then blow it out of air. You might want to use a number 8 tap. It's a little bit bigger, but you can see there's plenty of room. You know, you could use a number 8. I use a 6. So after you get the hole in the block drilled, pilot hole for the tap the hole, then get the next size drill bit that's going to let the screw pass through the plate. Drill that out. Then after you do that, use a tool like this. You can get it at Home Depot, at Ace Hardware. And then use this to get the countersink for the screw. Only do it enough to get the head of the screw below the surface of the plate. Okay, now you see I have the holes drilled in the block and I have the holes drilled in the plate. And you can see I used a small tapered drill to countersink the head of the screw. Make sure that it's below the surface of the aluminum. If the screw's too long, you know, like that's a lot of material right there. It's too long, or you didn't drill a hole deep enough. Remember, it's just to be this is just to keep oil from coming out between the manifold and the block. So the screw does not have to be that long. So what you can do is you can use one of these, you know, like a pair of wire crimpers. They usually have the holes around the around here. Those holes are for cutting screws. So just cut your screw down, because you don't want to have the screw bottom out on the bottom of the hole. If it bottoms out on the bottom of the hole before it's tight, you're going to end up snapping the screw off. If you snap a screw off that's bottomed out, you can't use an easy out to get it out. So you have to start all over again. I drilled one hole, I tapped it, put the screw in, it's right depth, it's below the surface of the plate. Now I have the other hole drilled for the screw, and I'm going to take the drill and then you're going to stick it in the hole for the screw, and then you're going to go ahead and drill down, and then you're going to make a mark. Take drill out. Don't try to drill the hole in one shot. I figured out where the hole is going to be. Take the screw out, take the plate off. Take your time, otherwise you're definitely going to screw it up. And then got the hole, it's right there in the center of the webbing of the casting on it, the block. And then you're going to take the drill and you're going to finish drilling it, then you're going to tap it. Don't go crazy, don't go drilling a hole in a oil cavity or anything like that. Just take your time. Okay, now I've got it screwed down. It's not permanent because I still have to take the heads off and put the rest of the lifters in, put the push rods in, adjust the valves and all that. But you want to get it all set up so that when you're ready to put the intake manifold on, you're just going to glue down the plates, screw them, and then put the silicone on top. And you want about 30 thousandths clearance between the manifold and the top of this plate. So you're going to want to put the manifold on first, torque it down close to what you need it at without any glue or anything, to figure out, you know, that I needed a 3/16 plate. Now that's a lot. Make sure that you put plastic caps in all the holes. You know, you drop a tap, you don't think it's going to happen, you drop a tap down there or a screw and you'll be hating life, especially if you don't have the rest of the motor taken apart. This motor's all ready to go back together. This is just the last thing I'm doing. Now that the plates are finished, we're going to do a mock-up assembly with the plates in place, just to make sure before you're putting the motor together that, yeah, okay, we got about 20-25 thousandths clearance. You don't want it perfectly flat. You need some clearance for the silicone. At the same time, you might want to go ahead and run another line of white out on the gasket. You can see that the original line they put in is higher now that I trimmed the gasket, which I showed in the video about port matching the gasket. Just because you buy a gasket doesn't mean it fits. So we're in the back here now. See a little bit of clearance on top of this area. And this is the other problem that the Ford has. It's wacky casting. When you put it all together, there's a big ass cavity here, and this wacky casting sticking way over the block deck here. So when you put it together with silicone, you can't get your fingers underneath here or underneath this section that's sticking over this deck. So this plate makes it nice. So when you're done, you just smooth all that in. During the mock-up assembly, when you put the manifold on, you want to make sure that you got port match. You can see the intake matches perfectly with the head. You know, people say, oh, I don't want to pay to have it done. Well, you can see Ron Robart, he does perfect work. It's worth every dime that you spend. But once again, you have to check everybody's work. Just because you hire someone to do a job doesn't mean they did it. But on the other hand, Ron does very good work. Okay, I removed the intake manifold after the mock-up, and right before I removed it, I put the white out. I ran it across. Now you can see that this gasket lined up pretty well. In other words, you got enough space here. You know, it's not dangerous. Now you're wondering how I got it, you know, to sit like this. I put a little bit of glue, you know, contact cement, like weather adhesive, and like a size of a pencil eraser, just a tiny bit amount behind here and here. That way, if the paper rips a little bit, it's not going to make much of a difference. Now on the other side, I'm going to have to reposition it because it's too close for comfort. It's not close enough. So what I'm going to have to do is I'm going to have to lower the gasket. Raise the gasket just a little bit. What the hell am I talking about? Lowering it. I'll lower the gasket a little bit. And then after you find a happy spot for it, then take a magic marker and mark all the holes, trace all the holes all around. That way when you go to put the gasket back on after you get your heads torqued right and everything's ready to go, then you just take your magic marker, mark everything, we put the gasket back in the same spot. Just because you buy a gasket doesn't mean it's going to fit. You know, I trimmed about 200 thousandths off the top of each one of these gaskets with a straight edge because it was coming up at an angle, wasn't matching at all. So these are trick flow gaskets. Even though they're for these heads, they fit like crap. That's why you got to check it over and over.